is Mike Scott. I'm principal of the London College, and this is our campus. As you can see behind me, we have quite a significant building, of which we have the whole of the building, and we have our laboratories and classrooms all situated both on the ground floor, first floor and second floor, and we look after all of our civil engineers as well as our general engineering students, along with all of our other Derby programs and Pearson programs.
Welcome to the introduction to our labs that we have here in the London College UCK. These are our soil and structural labs. We have 3 labs in total, the soil and structure labs, which we have this room in part of for some experiments. We also have the hydraulics, which is next door, and also the concrete lab downstairs. I will hopefully be showing you all 3, or you'll see them in the confines of this video. To start with, we have some soil experiments. So here we mainly focus on things like the Atterberg limits, so mainly the liquid and plastic limits. We do some shrinkage experiments depending on the course and the kind of modules available. So this is the aggregate grading machine. So we obviously put some soil in, we turn it on, we have it shake. It'll separate the aggregates for us. We can measure each one and find the the sieve analysis of it. So percentage find out of each one, draw a graph from it. Basic stuff for the students. Very good for aggregate grading, especially in concrete making. I can turn it on and show you. I'm sure you know already. Basic introduction. Obviously, we like to keep it as close to health and safety measures as possible. We don't want to, do anything out of what is required of us. This is now a demonstration of the Triaxial test. It's going to be a very basic run through of it. Of course, we know there are 3 types of tests. We're mainly going to focus on the UU test. That's because the unconsolidated, undrained test, because usually the other 2 take too much time. Although we do and can show them, it's usually best for students, at least, for them to make notes just based on the UU test. It's much more understandable for them. But for the high level ones, we do try and do a mixture of the 3. So obviously this is a sample I have made earlier using the extractor and the pump. Just a soil, regular clay, bit malleable, bit plastic. So I can just place it on there, and I'll place the confining cell on top. So, as you can see, it's set up. Just make sure everything is in sync. Make sure that's in the right setting. And then we can easily just lock these screws in. There we go. And now, let's reset everything to 0. It should be on the right setting to start the experiment. As you can see. And of course we'd have this, also have some water for the experiment to work, which we have set up here. We would increase the pressure with this pump. There's a foot pump here. And that will give us hopefully the readings that we need to have this experiment set up. And of course we just have our readings set up in a very basic way to see how much deformation is being caused and the divisions of each one and how much load is being applied to the sample over time. Thank you. Hello. Welcome to the next set of soil experiments. This is the direct shear test, of course. It's one of the older ones, but it still works. It's part of the impact range. We have multiple of load cells which can read the deflection and displacement of the soil sample. It's not loaded just yet, but it's connected to a data logger. So when it is loaded and the shear is applied, we can have the graph and the data loaded onto the cell and onto our program onto the PC. So of course, we have two sizes. We have two sizes of the small one and the larger one, and of course we load them with the multiple components that we need to have, like the porous stone and the filter plate, which we have here. Available on both sizes, of course, which is good because then we can show different sizes for the students. As you can see, filter plate and porous stone, and in both sizes, of course. So that's kind of what we have in the lab. It's also, it's not loaded this, but I can still show you a demonstration of the experiment. So of course, if I apply a load, it will engage, and I can disassemble the load, or I can change the direction of the load. And of course, I'll stop it just now because we're not actually going to compress anything just yet. But that's all it is to it. Of course, we have the dead weights here, up 1, 2, 4, and 8 kilos, in case we need to have an adjunction of them. And that's pretty much it. Thank you very much. Hello again. This is the structural side of the lab that we have. It's a very small section, but it's pretty efficient when it comes to the understanding of students in terms of structural analysis and design. Of course, you already know of the deflection meter that we have, of course, to show deflection of a simply supported beam. I have gone through a small explanation of that. The other two I want to focus on today are the shear force in a beam and the bending moment diagram. These, of course, can be loaded on to show like a simulated example of loads on a beam, but we can also hook them up to the computer. These are part of the equipment range, and we can show, it can automatically draw shear force and bending moment diagrams straight away. That can be good after the students have a proper understanding of them, to prove or to help them understand it further along the way. Thank you very much. Hello, and welcome to our very small concrete lab. This is where we conduct any sort of concrete experiments, so anything to do with large-scale soil experiments. So if we have anything that would affect any kind of passive pressure or even large-scale soil experiments, we can do them here because we have more space, and it is outside, so the ventilation is much better for breathing and for hazards like that. Usually I would be wearing a P3 mask, especially when I deal with, we do have silica fume in this lab. It's now sealed, so there's no risk to me at this present moment. Ventilation ducts are open, we have windows and proper ventilation units available. Here we do store our concrete equipment. We also store some of the tripods for the surveying. The surveying machines themselves, we do store them upstairs. This is to reduce any sort of humidity or any sort of change in temperature which might affect the machinery or electronics of them therefore. So as you can see behind me, we have a mixer from a standard mixer. We have some waste. We also have some students' experiments lying around just waiting to be used. We have some rebar available, and if you follow me this way, here is our silica fume. Of course, when we mix it, the concrete, we will mainly mix it outside, of course, because of space, but also because of the hazards available with breathing, especially the respiratory illnesses which can arise. We have all sorts of things available. We have various sizes of ballast and aggregates. We have 0 to 20 mm. We also have silver sand and fine sand for mortar, less large stone-based experiments. Apologies, but if you look back over there, we also have the machine for testing flexural beams. So that will give us an idea about how much flexion there is, or testing the strength of beams, the flexural strength, rather than compressive or tensile. If you follow me, here we have some equipment for mixing the concrete and cement and the like. We also have a CBR test here. We don't use it as often as other apparatuses, but it's still pretty useful in terms of our studies. Curing tanks are available here. We also have, here is the main thing we use for the concrete experiments. Of course, to crush or to test compressive strength, we do place a cube in, for example, and it's a manual pump, and we just start to pump it gradually. In terms of a tensile strength, we do the same thing, except the cylinder, we turn it on its axis, so it's facing us, the head is facing us, and that will give us an indication of a tensile strength. It's kind of like a pseudo tensile strength test for that. We also have some of the molds here. So if you look at this is makeshift molds. So for beams, we have different sizes available for different thicknesses, depending on what the students are using and depending on the size of the rebars we would use in that rebar. That's pretty much it. It's a small lab, but we do make use of it very well. Lots of students like to do concrete experiments. It's also a speciality of many of the staff members, and it's a very straightforward and good to know about, especially in industry where it's heavily relied upon to use. Thank you again. Hello again. This is one of the surveying apparatuses we have. We have a variety of them upstairs. And like I said, we keep them upstairs to remove any risk of humidity or damage to them. This is basically just a socket. We place it on a tripod. It's ready to be used. Of course, we can lock it in place, we can move it around, we can lock it so it doesn't move. All the safety settings and accuracy are really available. Usually you'll have someone on the other end, of course, holding the bar, and then you can see the leveling or even any kind of level benchmarks or anything like that. In other words, it's just one of the other facilities that we have in terms of the engineering labs. Thank you very much. Hi everyone, this is part of the geotechnic and soil mechanics, or geology and soil mechanics experiment. Next we're going to do the Proctor exam, the Proctor experiment. So what the point of the Proctor is to compact the soil as much as possible, to remove air voids as much as air voids as you can. You're going to be compacting it with the drop weight, and also using soil and some water. The exact ratios you should have. Usually we like to air dry the soil before we use it, but in this case we're going to be using some pre-wet soil already ready for the Proctor. We might add some moisture depending on the weight, and we will use the moisture meter as you've seen me use prior, the moisture meter. This will give us an idea about the moisture before and after the experiment. Hello everyone, here we are using the deflection machine to figure out the deflection of a beam. We're going to try and find the deflection using this dial. We're going to use that to find the dimensions, and then we're going to use all those numbers to find the Young's modulus of each beam. We're going to use 3 different beams: the timber or wood, the steel, and the aluminium. And we're going to put 5 different loads on it: the 100, 2, 3, 4, and 500 gram loads. Hi, welcome everyone. This is the moisture content in ballast experiment. What we're going to do with this one is a very short experiment. We're going to see the moisture content within types of ballast. For example, this London soil, normal London soil, we have mixed with silt, sand, gravel, pebbles. We also have some silver sand. We'll be looking at one today and trying to see how much moisture there is based on in a short amount of time we have in the lab. So first things first, we'll start with an empty container. We want to weigh it empty first, just so we know the weight. So we're going to put onto here the weighing scale. We have it as about 50 grams, 52 grams. That's the weight of this beaker. So we know 52. And next we're going to fill it up with the soil. Now with the soil I like to fill it halfway, because sometimes sometimes it'll be harder to make. Sometimes when you put it in the oven to dry, you'll have some problems adjusting it if it's too full. So best thing to do is fill it up to, here we have 50 as the halfway point. So this is about 25 milliliter scoop. 2 scoops should be enough to fill it to 50. Put it in the oven. We dried it for about 5 minutes at least 105 degrees Celsius. Usually if you want to completely dry something out using heat or the oven, you usually keep it for 24 hours roughly. But 105 degrees usually is the temperature we keep it at, just as in case 100 degrees is the boiling point, of course, for water. So 105 we keep it as a assurance for that. So now we're going to take it out using the clamp. Always make sure you use a clamp and any tools you have, and so you don't burn your hand. So I'll be taking it out. Onto the here we have a weighing scale placed on here. You see 154 grams, so we have a 2 gram difference since we dried it for 5 minutes.